Hi everyone, from Gothenburg and HSB Living Lab. My name is Eva Kuraki and I work at Johanneberry Science Park. Johanneberry Science Park is one of the main partners of HSB Living Lab, together with HSB and Chalmers University of Technology. Our role has been to contribute to the dissemination of the results from the project, but also to connect with new actors like innovators, small companies, researchers in the premises of the lab. We will now take a closer look to MinSed project. MinSed project is about minimizing microplastics while washing clothes. Johanneberry Science Park has contributed to connect this project to HSB Living Lab premises. And now we are going inside to meet Sebastian Rauch from Chalmers University of Technology, who is the main coordinator of the testing in the lab.
Hi, my name is Sebastian Rauch and I'm a professor of urban environment and systems at the Division of Water and Environment Technology at the Department of Architecture and Civil Engineering at Chalmers. And I've been working in the Living Lab on a project that deals with microplastic emission from laundry. This project is part of a larger project called MinShed that involves RISE as the coordinator, as well as a number of companies dealing, for instance, with fashion, making clothes, as well as companies producing washing machines such as Electrolux, or companies dealing with microplastic emissions such as Stop Micro Waste. In that project, the main purpose was to test in the Living Lab the emission of microplastics under real-life conditions, to see if the emission was the same as what is found in the lab, and to be able to measure the emission rates. So we are about 8 billion people on the planet, and something that most of us share is that we wear clothes. So we are almost 8 billion people wearing clothes. And when we wear clothes, we need to wash them. And when we wash them, there is some emission of fiber. All the clothes are made of textile fibers or fibers, and a small amount of the fibers is emitted during the wash. It goes into the wastewater and ends up at the wastewater treatment plant, or it could end up in the rivers, in the streams, and in the sea. A large amount of the fibers used in textile are synthetic fibers. They include, for instance, polyester, polyethylene. And these microplastic fibers, when they are emitted, they are small pieces of fabric, small pieces of textiles, of fibers. When they are emitted, they are relatively small, and they are considered to be microplastics. Microplastic is a new problem in the environment that has been discussed in recent years because we have seen that they've increased almost everywhere in the environment, and we find them especially in the marine environment. A recent organism that has been discovered at the Mariana Trench, very deep in the Mariana Trench in the Pacific Oceans, contained microplastics. And this is an organism that lives in a very remote environment. And the fact that this organism already contained microplastic, there was a small fiber in the organism when they discovered it. That means that it's really very ubiquitous in the environment. We find it everywhere, and it can be taken up by organisms. The effect of microplastic on the organism or on the environment is very much unknown. We know that microplastics themselves may have very limited effect, but that they may, for instance, transport other contaminants and get them to go into organisms. So the risk of microplastic is there, and it needs to be studied. Since we don't know much about the risk, about the potential threat to health, to the environment, it is important that we already start to decrease the emission of microplastics into the environment. And that's what we are doing in the MinShed project. We are trying to limit the emission of microplastic emission from laundry. There are many sources of microplastics into the environment. That include, for instance, road and tire wear coming from traffic, from the roads. Laundry is one of the main sources of microplastics or microfibers into the environment. In Sweden, we do have wastewater treatment plants, and the treatment plants are very efficient at stopping the microplastics emission or the microplastic being released into the sea or into the environment. However, a large amount of the microplastics end up in the sludge, and if the sludge is to be reused in agriculture, for instance, that will lead to further emission of microplastics. In contrast, in developing countries, many places don't have a wastewater treatment plant. So the emission of laundry, so if you have microplastics in your emissions, the microplastics will directly go into the sea or into the rivers. And that means that you have a direct contamination of the environment without any way of stopping the emission. There are a number of reports of microplastics emission from laundry. However, the emission rates are very uncertain, because if you look at different papers, different articles published in the scientific literature, they have very different results in terms of emission rate. So we wanted to measure emission rates under real-life conditions, because many of the tests that have been done previously have been done in the lab. So our purpose in this project was to really measure the emission rate under real-life conditions. So we use actual washing machine, like this one, and we did test clothes, the full piece of clothes, because many of the tests that have been done previously use small pieces of fabric that have been made specifically for the test. So what we did is that we use commercially available clothes that we bought or we received from producers or from shops, and we did wash them, but we also use them, because the tests that have been done previously haven't been done on used clothes. They've been done on new clothes, and they've been tested without any use. And if we get clothes, it's not just to wash them, it's to use them. The idea of wearing the clothes came from personal experience, just because when we wear clothes, we see that there is some shedding, that the clothes get damaged. And especially one event when we were actually doing the test in the Living Lab, when we started doing the test, was that my son went to ski and he had a pair of new socks. And after one day, he put his shoes off and he took off his socks. And they were just like shedding fibers, a lot of fibers. They were fiber just like everywhere. So that led me to think that we really need to test actually wearing the clothes to see how that would affect the emission. So our purpose in this project was to really look at the real life situation. How do we wash the clothes under real situation with clothes that have been used? In the project, we used a number of clothing items made of synthetic material. They included fleece, t-shirts, leggings, training pants, as well as socks. And we have washed them first without any use. And then we have another batch of clothes which is similar that we use between the washes. All the clothes have been washed up to 5 times. And we wash them in batches to have enough material being released, because the fibers are actually very difficult to measure. There are a lot of fibers being emitted, but in terms of weight, they're very, very light. So measuring the weight is much easier if you have a lot of clothes in your machine compared to having an empty machine. So here is some material that we use for the project. We do have some of the clothes that we used. For instance, one of the t-shirts that we have worn and that we have washed for the project. One of the fleeces we have used is here as well. Also, if the washing machine is half full, so with not too much clothes, the effect on the clothes is relatively small. If the washing machine is, for instance, almost empty with only maybe one item, like one t-shirt, it will damage the clothes, the t-shirt, much quicker compared to if it's half full. So therefore, we decided to have a few items in every wash. So we wash, for instance, 3 t-shirts together, not only one t-shirt, to have enough material, as well as try to minimize the effect of the washing on the clothes. So we did wash the clothes that we use for the experiments in the machine, which is this machine. We put the clothes, as everybody does when they wash, we put the clothes in the machine like normal. And we use a specific program which has, as I said, 40 degrees and detergent, but no softener. And the particle that came out, this microfiber, the fiber coming out from the clothes when you wash, were collected at the outlet of the machine at this point using a filter. The filter has a small mesh so that the particles could be collected on the filter without going out through the effluent. And we took the filter to the lab, and there we did some tests. We checked the weight of the material that was emitted, especially because the weight is the easiest thing to measure. So we checked the weight of the fibers on the filter. Then we also look at the particles under a microscope and we try to count them. However, it is very difficult to count because when you have a wash, you may emit over 1 million fiber particles. So it's really a very large amount of fibers, not very much weight because they are very light, but a large amount of fibers. So we did as well do the microscopy part to try to count the fibers, but in addition to this, we took the material that we wash, the textile, and we went to analyze them with an electron microscope to see how the fibers were actually damaged and try to understand why the emission happened. The emission rate decreased with the increase in number of wash. So the more you wash, the less you have emission, because a lot of the fibers are maybe loose when you get the new clothes and they're not well fixed. So when you wash the first time, you have a higher emission rate. So the emission rate decreased with the number of washes. However, what we saw that when we tried to wash the clothes, to use the clothes between the washes, we had an increase in emission rate. And the increase was larger for some clothing items, and that was especially for the socks. The socks were found to be more damaged. So when you wear the socks, you have more compression, more friction, and that affects the emission rate. We saw that a lot of the fibers on the socks were broken, and that they could be released using this through this process. On this picture, which comes from an electron microscope, you can see how the fibers are actually damaged. So you can really see the compression on the fibers and the fact that they are disformed or their shape is changed, and how this could affect the emission is really very clear from the picture itself. One of the most interesting results in this study is that wearing the clothes would affect the emission rate. This is of course something that I think is obvious, but it's something that hasn't been measured before. So we did find this higher emission rate when we wear the clothes, and that means that the previous measurements have probably underestimated the actual emission rates. So we do emit much more than was actually previously thought, and that's something we discovered through these experiments in the Living Lab. So what do we do about the emission? We focus our project on measuring the emission rate because we think that it's still very much unknown how much is emitted from laundry. But we also need to find solutions and try to avoid emission of microplastics. So there are different solutions to that. One solution is to use a bag that is a type of filter in which you put in your clothes before you put them in the washing machine. And this bag will not only protect your clothes from damage, it will also collect the fibers and avoid the emission into the effluent. Another solution is that you can have a filter at the effluent level. So you put the filter like what we did in our experiment where we collected the particles. So you put a filter there to avoid the emission and stopping what is coming out of the washing machine. There is also a startup at Chalmers called Mimbly that I want to mention, and they do work with a system that recycles water. So they take the water that comes out and put it back in the washing machine. And when they do this in the same process, they do collect the fibers, and they avoid that the fiber get emitted into the environment in this way. So we know that microplastics are emitted from laundry, and there are different types of solutions to the problem. One solution is, of course, to make better clothes that release less fibers, and this is something that the fashion industry is working with. So we provided the results to the companies involved in the Mindshed project, and there are many of the Swedish, especially outdoor companies, but also the large commercial fashion companies in Sweden. Another way is to work on the washing machine themselves and try to maybe put a filter like what we did in our experiments. However, this is not so easy, partly because there are safety issues when it comes to washing machine. It is possible to wash on some machines up to 90 degrees, and therefore putting a filter and having a risk that if the filter is clogged, the outflow is overflowing is a big risk for making a washing machine. Therefore, it's not so easy. However, in France now, and possibly later in more European countries, there is a new law that will enforce in the near future companies making washing machines to install a filter or a device on the washing machine to reduce the emission of microplastics from laundry.